Basic Calculus Part 7 and Graph Sketching Part 3 of 4. Now we're being given the actual curve and we're told to find aspects of the equation of the curve, the original definition of the curve. Well, if we're given the turning points, that's told us the derivative is 0 at -1, x equals -1, and 0 at x equals 3. But we've also been given 2 points. So it means if I take that and substitute into the original, it must be true, and that into the original must be true. So 4 facts. They lie on the curve, and f prime x equals 0 at those x values. I'm going to use the derivative because that means it gets rid of the c for now. So we're only dealing with 2 variables. Substitute -1 into the derivative equal to 0 and gives us that equation. Do the same with 3. So we now have 2 equations. We're going to do simultaneous equations. Easiest way, if I add, you'll see that the b's go. So let's add those equations. You'll get 8a equals minus 24. Means a is minus 3. Now I can just substitute back into there or there. We'll go to 1. And we get b equal to -9. Now that we have that, we have quite a bit of that equation. The only thing left to find is c. So now we can use one of those 2 points. When I substitute in, I get an equation for c. And I get c equal to -4. And it's finished. Find the values of a, b, and c. We've done so. Here are some examples for you to try. Pause, try them yourself first. This first one, we're given 4 facts. F of 1 is 4 because that lies on the curve. F prime of 1 equals 0 because it's a turning point there. F of -1 equals 0 because that lies on the curve, and f prime -1 equals 0 because if I substitute -1 into the derivative, I'll get 0 for a turning point. There's my derivative. I'm starting with the derivative to get rid of the c for now. And that gives me 2 equations. Solving for a, substitute to find b. So far now I have the values of a and b. So minus x cubed plus 0x squared, therefore no x squared, plus 3x plus c. Now I can take one of these 2 values that are sitting on standby, or the other one, substitute in, and I get my c value. This says prove that a equals -3, b equals 0, c equals 4. So now we have it. And it says here, while you can substitute these and show the turning points turn out as those, it's not a good idea because some people may argue that you've just proven the converse. This says, if this is the case, prove that. So if you take these in and find that, you've shown that if this is the case, then that is the case. And it's actually arguable as to whether you can lose marks or not. Just don't tempt fate. So we're going to go through the usual procedure. That's quite useful. I already have b equal to 0. See, turning point at x equals 0 means if I substitute this into the derivative, I'm going to get 0. So f prime of 0 equals 0. There's the derivative. I substitute 0 and I get b equal to 0. F prime 2 equals 0. Substitute b equals 0 at that stage. We get a equal to -3. Now we could substitute back other ways, but I know that if Because it says to you that 0, 4 is on the curve, that means that C must be 4, because that'll be the y-intercept. B. Determine the equation of the tangent at x equals 1. So I now substitute 1 into the derivative to get the gradient. 1 into the original equation. Notice using these values of x1, a, b, and c, I get the point. I can use my y minus y1 equals mx minus x1, and we simplify. Does the tangent cut the graph again? Y equals minus 3x plus 5. Why doesn't it? Well, have a look. It's going to go through the point of inflection.